This video is meant as homework for August 28th, August 29th, due August 30th, August 31st. Really, we're just looking at the graphs of sine and cosine. However, I will ask follow-up questions that will be graded on August 30th and August 31st when you first come to class about these graphs. But let's talk about the graph of sine of x. This video is going to be dealing with the graph of sine of x, and then the second video will be cosine of x. But the idea is that this is our function, and these are the x values that we're actually going to input into our function. Hopefully we notice that these x values are all values that we can find on the unit circle. So for example, what's happening here is we're going to plug in the values into sine, meaning here I'm going to go down to 2 pi. If we have sine and our x value is 2 pi, then we're plugging 2 pi in for x. You're going to need your unit circle, or a unit circle. So if you can get one of those out, that would be great, so we can refer to it, because I'm going to refer to it. But if we look at 2 pi, sine is the y-coordinate, so sine of 2 pi would be 0. And we can get an ordered pair from here. So our x value was 2 pi, our output is 0. So we can get an ordered pair 2 pi comma 0. Similarly, we could do sine of 3 pi over 2, which would give us -1. So that ordered pair would be 3 pi over 2 comma -1. And we can keep doing this. I'm going to go ahead and fill it out, kind of talk about it. If you need to pause at any moment, please feel free to do so. At pi, sine is going to be 0. At pi over 2, sine is going to be 1. Pi over 6, sine is going to be 1/2. This will be 0. Negative pi over 6, so think about it this way. If this is going to be positive pi over 6, moving this way. Negative pi over 6, we're moving in the opposite direction. So this would be -1/2. Negative pi over 2, which is coterminal with 3 pi over 2, which means that sine would be -1, 0, 1, and 0. So I didn't list all of the ordered pairs just because we were getting really close to the graph, and so I didn't want to list those all. The idea though here is that we choose x values that fall on our unit circle, and then we plug that into our function to actually get the y values. All right. Now you might be thinking, well, x is cosine, sine is y. Yes, if we're dealing with the ordered pairs on the unit circle. These are the values that we're actually plugging into the function. So it's a little different than the unit circle. Yes, we're using it, but we're not actually plotting these pairs on the unit circle per se. But now we can go ahead and scale our axes. Our highest value, let's say we want to go as far up as 2 pi, as low as -2 pi. Then I can do that on the x and y plane. Let's call this 2 pi, -2 pi, and then I'm going to just do cut it into fourths in both direction. So this would be, if this is 2 pi, then halfway would be pi. This would be pi over 2 and 3 pi over 2. Similar, going the opposite direction. This would be -pi over 2, -pi, and -3 pi over 2. So that takes That takes care of the x values that we input into our function. Yeah, we do have this pi over 6 and -pi over 6. I'm going to talk about that in a second. We're just going to approximate that. And we can also take care of our y values. If we look at the table of values, it seems that our largest value is going to be 1. Our smaller value is going to be -1. So here, highest value is going to be 1. Lower value, -1. And now we just plot points. So for example, here I have the point 2 pi comma 0. So I go over to the right 2 pi comma 0 would be here. You can do the same thing for 3 pi over 2, 3 pi over 2 comma -1. Pi comma 0, pi over 2 comma 1. Pi over 6 comma 1/2. So pi over 6 That's going to be around here. We can go to 1/2. So let's say that's pi over 6 comma 1/2. 0 comma 0. Negative pi over 6. Let's call this negative 1/2. Negative pi over 2 comma negative 1. Negative pi comma 0. Negative 3 pi over 2 comma 1. And negative 2 pi comma 0. Roll up a little bit. So we were able to obtain the ordered pairs using the unit circle. We can plot those ordered pairs here on our actual XY plane. And now we can connect the graph. It looks like just a lot of dots, like boom, 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 boom. But the reason I chose the pi over 6, the positive pi over 6 and the negative pi over 6, is that so we can see if we go in the positive direction, then we can see that it kind of is going to go up. And then as it gets closer to pi over 2, it's going to take this like mounded shape. And then it's going to come down through pi comma 0. So it's going to do something like this. My drawings aren't going to be great. The idea is that you get the general shape. So that's what our sine function is going to look like, moving in the positive direction. And if we wanted to go into the negative direction, then what's going to happen is it's going to look something like this. Yeah, I kind of get messy there. Oh well. And this is our function sine of x. So this is what we call the parent function for sine of x. We're going to see what that means. Even on August 30th or 31st, we're going to see exactly what that means to be a parent function. But you've graphed sine of x. That's the key. And the bigger key is that we use, what we can do is, and I'm going to ask you to rephrase this on either Wednesday or Thursday for a grade, is that we can use values that fall on our unit circle, whether coterminal or just plain that fall on our unit circle, get the output in terms of what the sine value is there, obtain ordered pairs, and actually graph the function using those ordered pairs. I'm going to end this video here. We're going to talk about key features and things like that, things that make this function stand out. We're going to talk about those on either Wednesday or Thursday. In the next video, we'll do something similar with cosine. So if I gave this to you in class, turn to the back side, cosine's there. I'm going to graph that in the next video. If you printed this off, probably on the second page is graph cosine.